Bearings, speed, distance and time. Bearings are very similar to angles that we've covered in the past, but there's some rules you need to know about bearings that makes them different from angles. Speed, distance, time. We've done speed, distance, time with respect to the speed, distance, time triangle. Today we're going to sweep up a few things that you might not have seen, like timetables, manipulating time from timetables. We've got distance charts, and we've got some line distance charts to show you. So a couple of displays that come up quite regularly in the exams that you might not have seen in what we've covered so far. Right, your smart recap. 3 questions for you to start with. You will need pencils, pens, rulers, protractors. Today you are going to be doing a lot of stuff for me. So the first one is a recap on what we did last week, but it plays a part in what we're going to be doing today. How many degrees are in a quarter turn? The next one, I want you to draw the speed, distance, time triangle. You won't believe how many people do not know the way round that the letters go. So we're just going to do a recap on the speed, distance, time triangle. And then finally, I'd like you to write down what 1.2 hours is in minutes. So how many degrees in a quarter turn?
90.
90, good. So everyone remembers last week.
Oh yeah.
Okay. And when we're talking about bearings, a quarter turn is the difference between north and east. So we use them quite a lot in bearings. Yeah? So the whole point of saying a quarter turn, if you're on a bearing, is you're adding how much? 90 degrees. Good. So don't let them catch you out with a question like that. Right, the dreaded speed, distance, time triangle. I'll do the difficult bit. I'll draw the triangle. Okay. That's our speed, distance, time triangle. Big question. What's at the top?
You draw a line through the top.
You can do it if you want. You don't have to draw the line. So what's at the top?
Speed.
Speed. Speed.
Speed.
Speed.
Might be time.
Speed. I'm with you, Chris. Distance. Because distance is speed times time. You need to remember that, or you will get your speed, distance, time calculations very, very wrong. Okay? So remember that. And how do we use it? Remember how we use the speed, distance, time triangle? Good. Yeah, and as we were saying, Sam was saying, you cover up the one that you don't know. So if I give you a distance, like 10 miles, and I do it in 2 hours, so I've got the distance and the time, I don't know the speed, you cover up the speed and it tells you divide the 10 miles by the 2 hours to get 5 miles per hour. You see how that works?
Yeah.
You happy with that? So remember, D is at the top of your speed, distance, time triangle, and you cover up the thing you don't know, and it tells you what to do with the 2 things you do know. Okay, that's really important. And then finally, 1.2 hours, how many minutes?
80.
80? 70? Amber? Going to be slightly more than 60, isn't it? 72 over the right. Gents, tell me how you got 72.
0.2 is a fifth of an hour.
0.2 is the same as 1/5.
And then it's 12 minutes.
So if you divide 60 by 5, it gives you 12 minutes. Good. And then you've got the 1 hour, which is 60 minutes. You add the 12 minutes to give you 72 minutes. Okay? The thing to remember with decimal time is that 0.1 of an hour is 6 minutes. So 0.2 is 12 and so on. So if you can remember that, it will help you with decimal time. If you're talking about minutes and seconds, 0.1 of a minute is the same, 6 seconds. Okay? Because it's a factor of 60, isn't it? We change around after we get to 60. So 1/10 of 60 is 6. So we're working in this base 6, okay? So that's why 0.2 is 12 minutes. Yeah, because 0.1 is 6 minutes. Good. Right, let's start the lesson proper then. Let's get to the main course. Bearings. Anybody tell me what a bearing is?
Just about how far it is, isn't it?
Sorry?
It's like how far it is, isn't it?
Not how far it is.
Where something is, like north.
Where something is. Good. So it's a direction. What's the direction specifically of a bearing relative to? North. Good. Yeah? So a bearing is relative to something, a course usually, and that course is usually compass points. Last week I asked you to find out what cardinal points were. At the end of the lesson you were learning outside the classroom. was what is a cardinal point? What are the cardinal points?
Is
The
it
points were
point between the main? Or
Points between the main.
like
The main. It's the main. So which ones are the main? I've got a load of letters on there.
North, south, east,
Good.
west.
So the cardinal points are north. Where does south go?
Bottom.
East.
Never eat shredded wheat.
Never eat shredded wheat. It's the other way. That's a good way of remembering it. So they are the cardinal points. In between them, and all you really need to know at this level, we have these.
That's where we are, northwest.
Oh, sorry, wrong way. Nobody corrected me. There we go. We have those. What are they called? So the green letters, so we know the orange are the cardinal points. The green letters are
Uncardinal.
close. It's got something cardinal.
Definitely not Carl Newman then.
County cardinal.
In betweeny cardinals.
semi-cardinal.
Semi-cardinals, good. I like your way that you're thinking.
Multiple cardinal?
Multiple cardinals. They're called the intercardinals. So the intercardinals are northeast, southeast, southwest and northwest. The purple ones
How do you get
you don't need to know for GCSE foundation level. My dog Archie is lost on the beach and he wants to get back to our house. Okay, that's not really my house. What heading does he have to go to? Good, northeast. Just generally, it's good for general stuff. He's lost his ball. Which way is he going to head? Southeast. His bone is
west?
right. And if something is exactly west, you say what? Have you heard of an expression? Might be a film actually. What do you say when something is exactly west?
West side.
Have you ever heard of due west? No, don't let it throw you when you see it in an exam paper. If something says it's due north or due west or due south, it means it's exactly west, it's exactly north, it's exactly south. So don't let the word due throw you in an exam. So if it says such and such is due west of, it's just saying it's absolutely west of it. Okay? Good. So, north, south, east, west and the intercardinals have got their limitations. It's not very good in a scenario where you have an aircraft huddling round an airport to come in and land. Because you can't put them all on the cardinals or the intercardinals because they'd end up colliding. And you have to give them very, very specific bearings to keep ships apart, aircraft apart and so on. Okay? Because with a very small bearing change, the further that thing goes, and aircraft travel very fast, the distance becomes massive very quickly. So if you're off by a couple of degrees here, this distance over 100 miles can be massive. So you have to be able to give accurate bearings. So the cardinals and the intercardinals aren't good enough. So we're going to look at some rules for giving bearings. So what's rule 1, do you reckon? What did we say bearings are relative to?
North.
North. So rule 1 states, whatever I do, I've got to reference the bearing to north. Okay? Rule 2, I want to give a bearing. I'm not going to give you a bearing now. If that angle there is 40 degrees, okay, what is the bearing that that aircraft is flying on?
Northwest.
It's sort of northwest, but I want a number. 320, John. How did you get 320?
Because it's a circle, 360. And
Good.
When you do a bearing, you start from north and go clockwise.
Good. So rule number 2 is you've always got to go clockwise. That's why you have pen and paper, it helps. Okay? So rule 1 is you reference it to north, and rule 2 is you've got to go clockwise round. So in this instance here that we've drawn on the aircraft, I can't give 40 degrees as a bearing because it could be the other way. It could be that direction and 40. So the rule is you've got to go clockwise around and work out your bearing. So we know there are 360 degrees in a circle. So 360, take away the 40 that we've been given, gives us a bearing of 320 degrees for that aircraft. Are you happy with that? Yeah? Rule number 3, we're going to look at a different scenario. Our aircraft is flying in that direction. So what's rule number 1?
No.
North.
Reference it to north. Good. That's our reference. Rule number 2.
Clockwise.
Got got to go clockwise round. I haven't got a problem now, and I measure that angle of 40 degrees. So what do you think rule number 3 is?
Anti-clockwise.
No. So I've done the 2 things that I need to do, and I've measured an angle of 40 degrees. But that angle isn't a bearing for some reason. Because when we're giving bearings, we don't want any confusion with aircraft and ships and so on, okay? So we don't say 40. What would we say to give that?
Minus.
No. No, it's kind of, it's more to do with the numbers and how many numbers there are.
40.
Close. You have to have 3 digits. So 40 degrees as an angle becomes 040 as a bearing. So there has to be 3 digits. And the reason we use 3 digits is it avoids confusion when you're giving accurate bearings. So it stops people saying, go on a bearing of 25. You say 025. And it gets rid of any ambiguity because you're always expecting 3 digits.
What,
So the third rule of bearings, and it's only 3, is 3 digits.
what would you do if you gave them? It sounds daft. What would you do if you gave them just 25 though? Like, would it like confuse completely?
Yes, because every pilot, every ship captain is expecting 3 digits as a bearing. And you want to avoid confusion. You might hear things. Radios aren't particularly clear when you're on an aircraft or on a ship and you're talking over long distances and they're crackly and there's interference. You want to make sure the guy at the other end receives the message the first time, especially on an airplane when you're travelling really fast. So you say 025 degrees. You don't say 25 degrees, that's it. Okay? So there are our 3 rules of bearings, and I want you to adhere to these for the rest of the lesson. Okay? You're happy with those? They're quite straightforward, and we'll practice them a bit together, and then I'll give you a chance at doing them. Okay? So, just black and white, the 3 rules of bearing. Always reference it to north, always measure it round clockwise, and always have 3 digits. 3 simple rules that, trust me, some of you will get wrong by the time I give you the worksheets. Okay. So, what I've got for you first is a card matching exercise. Because the generic bearings of north, south, east and west, the cardinals and the intercardinals, have got numbers associated with them, and an arrow, a direction, I want you to sort these cards so that the arrow points to the direction in words that relates to the bearing in numbers. So that's the first objective. The first objective is really quite basic, that you understand the rules of bearing, which are what? What's number 1?
North.
North. 2.
Clockwise.
3.
3 digits.
Brilliant. Okay? They're the rules of bearing, and that you know the cardinals and the intercardinals and how they relate to the numbers. Is everyone happy with the objectives then?
Yeah.
Yeah? Excellent. Let's move on to the next bit, where we're going to be a bit more practical, a bit more hands-on. We're going to get you measuring stuff, okay? So I'm going to show you the techniques for doing these measurings of bearings, okay? And you're going to put it into practice with a couple of worksheets, or just one worksheet. So what bearing is the hiker walking on? So the hiker started off, say, from Ambleside here, and he set off. Before I even measure it, what kind of bearing am I expecting, very roughly?
North.
390.
Oh,
Southeast, which is roughly, give me a number.
between 180 and 100.
Just roughly, it doesn't have to be exact. 120-ish. Yeah, we've done this with angles before. Remember earlier in the course, I'd say to you, what's this angle here? And you go, oh, it's about 30. It's the same with bearings. Have an idea of what you're expecting before you measure it, so that when you do measure it, you're not a mile out. Okay? So, to measure a bearing, rule 1.
No.
Has to be referenced to north. So I set off from Ambleside, I need a reference line at Ambleside.
Clockwise.
I've got to go clockwise, so I'm going to measure the bearing that way round. So I get my protractor, I rotate it, and I line it with my reference to north, and I put my crosshairs where I set off on my walk. And then, quite straightforward, I read around the protractor from 0 to about 125 degrees. That's pretty good. Is everyone happy with that as a bearing? We had an estimate of 120. We've measured it accurately with the protractor, and it's 125 degrees. So it's where we expect it to be. Everyone happy with that process? Slightly harder when we have a bearing there. Roughly, what sort of bearing is that ship sailing on?
270 to 300.
Good. So we know it's bigger than 270. So it's roughly 300-ish.
Matt, is that 315? To be exactly.
We'll find out in a second. Okay? So rule 1 says what to work out the bearing of the ship? Got to go from north, and
Clockwise.
rule 2, you've got to measure the angle there. So we've got a bit of a dilemma when we're measuring now, because our protractor has only got half a circle. And if we did what we did last time,
Just add 180 on.
You're not just measure like that way round.
right, so we're going to measure it that way around. We'll put the crosshairs on our start point.
And then just add that angle to 180.
Good, so that's one way of doing it. You've got 180 here, and we're just going to add the number of degrees this way around. So you see it says 0, 10, 20, 30, 40, 50, 110 degrees. So we're going to add 110 to the 180 that we know take us halfway around. So it's 290 degrees. Yeah, as an accurate bearing. There's another way of doing it. You can do it either way.
When you measure the small angle.
Good. You can measure the small angle here as 10, 20, 30, 40, 50, 60, 70 degrees, and you take it away from 360 and it tells you it's 290. They both give you the same answer, whichever is easiest for you. If you like adding, do it that way. If you can do subtraction, do it that way. There's no difference. You're happy with measuring bearings?
Yeah.
Yeah, good, good, good. Okay, we need to cover something called a reciprocal bearing. And we've come across reciprocals before on this course. Does anybody know what a reciprocal bearing is off the top of their heads?
A repeat?
Sorry?
Is it a repeat?
Kind of. We did reciprocals when we did fractions. If I said to you 3/4, what is the reciprocal? And I looked it up in our glossary. We've definitely done it because it's in our glossary. What's the reciprocal of 3/4?
Does it mean put it in decimal?
Good, Sam. Did everyone catch that? The reciprocal of 3/4
Like the opposite.
is 4/3. It's the opposite. So guess what the reciprocal of a course is?
Opposite? Where
The
do you do
opposite way.
Like
So,
anti-clockwise.
So anti-clock.
sort of, if I'm walking in that direction and I think, oh, I've forgotten my lunch,
That way.
I need to come back the other way. Okay, so a reciprocal bearing is saying, I want to go home, what is that bearing? And there's a really, really easy way to do that. Okay? When he set off from Ambleside, or wherever this walker set off from, roughly what bearing was he doing when we measured it just now?
300, no, it's 290.
290.
Good. So we measured it relative to north, we went round and it was 290 degrees. Okay? So we know that is 290. To come home, what's an easy way of doing it?
70. Because you just take 290 from 360.
Not quite, not quite. I'm coming straight back in a straight line. So what have I got to do to 290?
Take it away from 180.
From 290, you've got to take away 180.
580.
It's on
Because you're coming in a straight line back. It's a straight line angle, yeah? So you're going in a straight line that way, and you've just turned straight back the way. So it's like, you know when you're marching, you do a 180 degree turn, yeah? That's what you call a 180 degree turn. When you turn around and go exactly the opposite way, you're turning 180 degrees, aren't you? So you need to take away that 180 degrees. So can you see that looks around 110? It is 110, yeah? By doing a simple maths problem. So to find a reciprocal bearing, which means I'm just turning and going back the way I came, you just take off 180 degrees if the angle is bigger than 180. Because, and let me show you a different example. What's my bearing roughly here? Top of your heads.
65.
45.
No. What do you need for a bearing?
North.
3 digits. So it's
060.
let's
What?
060.
That doesn't even make sense.
So he's roughly walking on a bearing of 060. Because we can eyeball these things now. We're getting good at this. I want to find the reciprocal bearing that he has to walk on to come home. Sorry, that way round, isn't it? Yeah? So what is the reciprocal bearing? Well, I can't take away 180 now, can I? So guess what I do with 180 when it's less than 180?
Yeah, add it
degrees?
onto it. Add it onto it.
Add it on. So 60 plus 180 this time gives me 240. And that bearing there, you can see, is 240. So if it's less than an 180, we add on 180 degrees, and if the bearing is greater than 180, to get the reciprocal, we take away 180 degrees. Does that make sense? Yeah? A nice straightforward way of doing reciprocal bearings.
So it's less than 180, we take it.
You add it. Because if it's less than 180, you'd end up with a negative number if you took 180 away. That's the way to think about it.
Add the bearing to 180.
You add the bearing, 060, to 180, and it tells you what the reciprocal is like that. Yeah? No measuring, just add 180. If the bearing was over here, like we had on the last one, and it was, I don't know, 290, and it's greater than 180 degrees, you take off 180, 110.
What was if it's 180 on the dot?
Then what's the opposite of 180? What's the opposite south? North. 000.
So that's the answer. So.
North is 000. North isn't 360. Okay? When you get to 359.9999, the next one up is not 360, it's 000. There's no such bearing as 360. Okay? So north is 000 every time. Okay?
Imagine doing that.
Are you happy with those reciprocal rules? So we've got our 3 rules of bearing. We've also got a rule for dealing with reciprocals. Good. Lots of smiles and nods. Let's practice. Have a go at those 3, and we'll go through them as a group, and then I'll give you some worksheets in a minute to have a practice on as well. So just have a go at those. What's the bearing and what's the reciprocal?
You have to draw it.
The first one, what is the bearing?
North, 35 degrees.
It's 035 degrees. So they will trick you and give you 35 degrees as an angle. 35 is not a bearing, it's an angle. You know it's an angle because it's only 2 digits. To be a bearing, rule 3, you have to have 3 digits. So the bearing for that first diagram is 035 degrees. Okay? The next one, what's the bearing?
090.
090. And the last one?
045.
No. What's rule number 2?
Clockwise.
So they will try and trick you and give you an angle like that and expect you to say 045 because it's wrong. Rule 2, you've got to go clockwise round. So we've got 360 and we take away 45 and we end up with 315 degrees. You happy with that? So this is how they're going to get you. This is how you're going to start hemorrhaging marks if you're not careful. You've got to think about the 3 rules of bearing. So the first one then, what do we need to do to get the reciprocal? Good, Anthony. Add 180 because it's less than 180, so it gives us 5, 1, 2. So the reciprocal, so if I got to here and thought, oh heck, I forgot me lunch, I want to go home, get my compass out, I need to put a bearing of 215 degrees on there. Good. The next one then, what's the reciprocal of 090?
270.
Good, because if that's due east, this is due west, 270. Happy? And the final, last one.
Take 180.
Take away 180, good. 5, 3, 1. 135 degrees. Okay? So I'm heading off in that direction. I get to here, I think, oh, forgot my lunch. I need to get back. That's your reciprocal. Okay? So that's reciprocals. I'm going to show you one more thing before I give you the worksheet and get you to do the hands-on stuff. And that is, how do you plot a bearing? If you're just given a blank sheet of paper and they say to you, plot a bearing of a ship heading in 230. Okay? What's the first thing you need?
Draw a straight line, rotating to north.
Draw a reference point. So reference point and draw north from that reference point. The second thing,
Anti-clockwise.
Measure 230 degrees.
clockwise around. So we're going to go around 230 roughly. So you're going to get your protractor, you're going to expand it, you're going to rotate it, and because it's greater than 180, it's going to be placed like that. We line it up with our north line, and where am I going to read to?
230.
Doing it your way, Lisa. If I've got 180 to here,
50.
you're 180 round to there, so I'm starting off with 0 here, so what have I got to add to 180? No?
50.
60.
50. Get your calculators out if you can't do it. 230 minus 180 is 50, so you need to add on another 50. So go round 10, 20, 30, 40, 50, put a mark on the paper, get rid of your protractor, draw your course of 230 and mark it so the examiner can see that you know what you're talking about. Okay? You happy with that?
Yeah.
Let's get you to do some hands-on stuff then. So this worksheet has got different tasks for you. Everyone done at least a question from 1, 2 and 3? Yeah? Okay, heads up, we'll carry on. Now we're going to cover, when we're given 2 points, how to work out the bearing of something from something else. So the word of means where you're going to end up. The key word in bearings is from, because the from word is a sign that that's your reference point. That's the thing you're going to draw your north line on. So in this example that's on the board, it says, what is the bearing of A from B? So I want to know A from B. So the from B means B becomes my reference. Before I ever measure anything, what am I expecting the bearing to be, roughly?
About 270.
270 would be a bit lower down, wouldn't it? Because it's due west 270.
About 280.
About 280. So I've not measured anything. I'm expecting it to be around 280. Take your protractor, do all the good things with the protractor, spin it round, align it to north, put it on the crosshairs, and I'm going to take away 10, 20, 30, 40, 50, 60, 75. So I'm going to take away 75 from 360.
25.
Pretty close guess. Pretty good. Yeah? Everyone happy with that? So the from and to thing, again, the key word is the from. So this time I want to know the bearing of B from A. So draw a line between the 2 points you're measuring the bearing. The from tells you what your reference becomes. Measuring it that way, what am I estimating the bearing to be?
135.
Sounds good to me. I haven't got any arguments with that. So when I measure it, I'm expecting it to be roughly 135. So you're happy with this from and to thing? Yeah? Not particularly difficult. I won't torture you with a video this morning. I won't get you to do that. So if we were looking at something in the practical world, in the real world, okay, and I wanted to know the bearing of Blackburn from Preston, what's my reference point? Preston. Because it's the from Preston. Draw a line from Preston, Blackburn, and to get my bearing, it's roughly what?
About 80.
90.
It's going to be bigger than 90, because due east is 90, and it's below that horizontal line, isn't it? About 95-ish. Good. Yeah? So, let's practice the of and from using a diagram of a holiday island. And you've got to work out some angles between various facilities on the island. Good, good. Excellent. That's the kind of bearings. One more thing on bearings, just in case it comes up. It's in the curriculum. I've never seen it as a question, and that is cross bearings. What they could do is give you a scenario where you've got to rescue somebody. And there are 2 radio stations at positions A and at position B. And they might say to you, somebody's at sea and they've got a radio on them and they want help. Radio A has got a fix and he's got him on a bearing of 035. I know it sounds stupid, but we used to do this in an aircraft. We'd take a fix, we'd fly along, we'd take another fix, and where your cross bearings are, that's where the guy was in the water. Okay, so it's very realistic. So from A, so you need your reference point, you go around clockwise, and on 035, you just draw a line out to infinity. Okay? For B, do the same, put a reference point, and it's 295, so from north, go around clockwise to 295, and draw a line out to infinity. Where the lines cross is the crosscut where your survivor is in the water. Okay? So you're happy with that, crosscuts. I'm showing it to you because it's never come up in an exam, but it is in the curriculum. Okay? So it's just a one-off, there you go. So is everybody happy now with measuring and drawing lines and bearings as opposed to angles? Yeah? Excellent. Right. What we're going to do now, we're going to spend about 20-25 minutes having a brush up on speed distance time. We've done speed distance time in the past, but there are some topics that come up that aren't particularly clear in the curriculum, but when you go through the papers, there are definitely examples of these kind of things, like timetables. That's a Preston bus timetable for a bus that I think comes here. You're not going to get anything as complicated as that. What they're more likely to do is give you something like this, okay? They're going to give you 4 or 5 destinations with 4 or 5 times going across. I'm going to ask you questions along the lines of, if I've got a job interview in Alton at 10:30 in the morning, what time do I have to catch the bus from Shotton? That kind of thing. So they're going to see if you can read a table, use common sense and say, if I need to be there for 10:30, then I need to catch this bus, and what time does it leave? 9 in the morning from Shotton. Okay? So basic reading of tables. I'm not going to insult you too much by getting you to do too many of those sorts of things. Okay? But here's an example of what they could do to you. Because it involves time, they can start asking you questions about time, whether it's decimal times or so on. So have a go at this one then, on reading a timetable. So trains from Birmingham to London. There are 6 trains that go between Birmingham and London. One of the trains takes more than 2 hours. Which one is it? Don't shout it out. And then the second part I'd like you to answer is work out the number of minutes train D takes to get from Birmingham to London. Okay? So there's 2 questions there, 3 marks, exam style question. So I'd like you to all have a go at them, and then we'll go through the 2 questions together. And it's far more important than pencils. Okay, so I'm going to give you a couple of minutes to look at them. Make sure you're happy with your answers. We're going to go through them because you need to be nailing these easy marks. But it's just a look-up table and a bit of times, okay? So which train takes more than 2 hours? Everyone get E. Really quickly, 1 mark, you don't have to show any working out, but for thoroughness, E, if you go along and add 2 hours to all of them, okay, add 2 hours to 6:35, it's 8:35, so that's less than 2, 7 becomes 9 and so on. But when you get to E and add 2 hours, it takes you to 9:45, which is before 9:59, so it therefore has to take longer than 2 hours. Work out the number of minutes train D takes to get from Birmingham to London. Adam?
94.
How did you do it?
I added an hour.
So 07:30 plus 1 hour
Is
gives 8:30.
Then half an hour,
So we're at 8:30 and we add another half an hour,
which is 90.
which is
9 o'clock.
9 o'clock.
And then,
Good.
then plus 4.
And then at 9 o'clock I need to add another 4 minutes, and that's
94.
09:04. When you add these together, I've got 1.5 hours plus that, so that's 94 minutes. Very good. Happy with that? Excellent. Distance tables is another format of information that they might be giving you on speed distance time diagrams, okay? Here is a complete table. Now when you look at the complete table, if I say the distance from Cardiff to Bristol is 45 miles, the distance from Bristol to Cardiff is also 45 miles. What they're saying is, if I go from here to there, it's the same as going from there to here. So they came up with this space-saving table. So you'll see tables like this, they're quite common. Every other paper has one of these distance tables in. Do not panic. All they've done is they've chopped off half the table, because it's pointless saying the distance from here to there is the same as there to here. So they give you this table at the bottom. So this table at the bottom is the thing that you're likely to come across. Quite likely. So you need to be able to read it. And a lot of people get confused because the names appear sort of diagonally as you go across. If, for example, I said, what's the distance from Bristol to Exeter? You go down the Bristol and across from Exeter, and they cross at 85 miles. Okay? So all you're doing is you're picking the 2 places and following straight lines to where they meet. Okay? You don't have to do any calculations or anything. They're just telling you that the distance from Bristol to Exeter is 85 miles. Is everyone happy with these diagonal tables? They're really popular. Lisa, you've got a frown on your face. Are you happy with what we're doing?
Well, if you want to find out like how long it takes for Bristol to go there.
you haven't got a time. So Bristol to Dover might be Bristol to Dover is 205 miles. They might say it takes me 3 hours, and then you can work out the speed. Or if they say you're travelling at 60 miles an hour, how long does it take you to go from Bristol to Dover? So they can add these extra bits to the question, okay? And then they're testing your speed, distance, time triangle. So if I said I'm travelling at 60 miles per hour, how long does it take? What goes at the top?
Distance.
So I've given you 205 miles and a speed of 60 miles an hour. So I'm looking for how long?
Time.
Time.
So it's the time, you cover up the time, and it says,
Divide.
205 by.
good, divide your distance 205 by your time of 60, whatever that is. I'm not going to do it off the top of my head because it's a nasty number. Do it on a calculator, we'll find out.
3.416.
Okay, let's call it 3.4 hours. How many hours and minutes is that?
3 hours
3 hours is good start. So that's 3 hours. How many minutes?
and 24.
180 minutes.
Yeah, that's 180 for 3 hours. And what about the 0.4? How many minutes is that?
204 minutes.
24 minutes. Because 0.1 of an hour is 6 minutes. So 0.4 is 4 times 6, which is 24 minutes. So 3 hours, 24 minutes.
So 0.1 of an hour is 6 minutes.
Yeah, this is what we did at the starter. Remember we had the smart starter? Okay? So 0.1 of an hour is 6 minutes. 0.1 of a minute is 6 seconds. Good things to remember. Good. Okay. So just practicing then from these diagonal tables. What's the distance from Cardiff to Exeter?
85.
110.
Oh yeah. 110. I thought
See your error? Yeah. It's important that you see what you do wrong. So that's good. So it's 110. Cardiff to Exeter. Different distance from Dover to Bristol.
85.
Bristol to Exeter.
205.
Slow down, Amber. Don't rush it. Dover to Bristol. Go along from Dover, come down from Bristol, 205. Okay. So don't race it, and especially in the exam. See this? Don't race it. Make sure you get the right one. Good. The last kind of format I want to show you are these distance lines. Okay, linked distances. The sorts of questions that have these, they will say, oh, the distance from A to B is 30 miles, the distance from B to C is 20 miles. What's the difference from A to C?
10.
A to C. Would you just add them together?
So it's,
50 miles.
yeah, so it's not difficult, this one. They might add another town and say D is 10 miles from C. What is the distance from B to D?
30.
Yeah, quite straightforward. Sometimes these diagrams throw people. The worst case scenario is they combine this diagram with the one that you've just done. So here's a question I'd like you to do yourselves, and we'll go through the answers. I want you to tell me the missing distances for A, B, C and D. So this A, what's the distance? Where are we measuring the distance between?
Woodhall and Toddington.
Yeah? So we're going between Toddington and Woodhall. So what's the distance between Toddington and Woodhall?
109.
109. 26 plus 44 plus 39. So A is 109. Let's have a look at B then. Where's that between?
Toddington and Crowell, whatever.
Toddington and Trowell. So I'm going from Toddington all the way to the far end to the Trowell services. And how far is that?
137 miles.
137 miles. Good. The next one is between.
Blackburn and Watford Gap.
It's between Scratchford and the Watford Gap. That's a nice easy one.
44.
44, we just need to read it. And then the final one is between
Toddington and Watford Gap.
Watford Gap and,
137.
where did you say?
Trowell.
Trowell. Distance between Watford Gap and Trowell?
67.
67. Good. So you've combined the two skills that we've just been talking about. The diagonal distance table with the straight line distance chart. Good. And that's all the objectives complete for today. So today we've described and used bearings. Everyone happy with the 3 rules of bearing? Rule 1,
Yeah.
North.
Rule 2,
Clockwise.
Rule 3. Brilliant. Measuring and drawing the angles. So you're happy when we're doing reciprocals. If it's greater than 180, what do we do?
Take
Take it.
take 100.
Good. Take away 180, and if it's less than 180, we add 180. Speed, distance, time charts. You've seen all of the combinations of them now, so don't let them catch you out on the big day. Any questions for me on what we've covered in the lesson